So this is an introduction to indicial notation. And the way we'll introduce this first is just talking about there's a variety of physical parameters or variables that we want to describe. First is scalars. So as you're familiar with things such as temperature, a potential such as electrostatic potential may also be a chemical potential. Variables are often of this sort. Vectors or first order tensors include things such as electric or magnetic field, velocity, and displacement. So they have a magnitude and direction. So electric field, magnetic field, velocity, displacements. Tensors include everything above first order vector. So tensors may be second order tensors such as stress strain, quadrupole, third order tensor, examples of piezoelectric tensor, fourth order tensor, elastic modulus. So often in my notes I'll use an underline, two underlines for second order tensor of stress, strain, quadrupole, third order piezoelectric tensor, three underlines, four for the elastic tensor. So the notation using indicial notation, or in first off what I call or what is known as dyadic notation, this describes the magnitude of this vector v. So let's just call this velocity. So this is the magnitude of the velocity in a particular direction. So this e hat is my unit normal. You're probably more familiar with how unit normals may be written as I hat, j hat, k hat. We're going to be summing on I here. So my I will sum 1, 2, and 3, which corresponds with 1, 2, and 3 directions. So if we expand this out, we have v1, e hat 1, v2, e hat 2, v3, e hat 2, e hat 3, or in terms of I hat, j hat, k hat shown here. So again, we have the components, these are the magnitudes, and the e's are my directions. So this is the first rule in indicial notation. Anytime you see a repeated indice, you're going to sum over 1, 2, and if it's 3D, the third direction. So all the rules of adding, multiplying, etc., those apply in using indicial notation as well. One important rule here is if we sum up two vectors, v and a, we're going to sum their components. So v1 plus a1 for the one direction, similar for the two direction, and the three. So we can also write this in more compact form in using the index notation. So these are my components in indicial notation, where C can be written out this way. So let's go higher order. Let's go with a tensor. So let's say we have a stress tensor. This has two unit normals associated with it. And if it's a stress, we're going to define one of these to define its direction of force. And then, if you know, familiar with stresses, each one of those forces have to be applied on the face of a material. So this unit normal defines the outward pointing normal on that particular face where the force is applied. Mathematically, note that we have a repeated indice I, repeated indice j. So that means we have to do a summation on I and j. So you're going to sum sigma 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, etc. down to sigma 3, 3. Same thing goes third order tensor. So you notice here I have three indices, three unit normals. Importantly, these are different indices for each direction. We would never have more than an indice repeated once. If you have three i's or three j's, you've done something wrong. since these are repeated ones, we're going to sum on I, j, and k. So that means if we were to sum all of these terms, so all of these terms here in 3D, we'll have 3 of these. For each one of these, we have to sum j 3 times. So that's 3 times 3, 9. And then for each one of those 9, we have to sum 3 more times. So 9 times 3, you get 27 terms that we would sum together. Even more terms if it's 4th order. So this is your elastic tensor. You have 4 directions. So 3 times 3 times 3 times 3, 81 terms. Okay, let's stop there.